In this video, I want to talk about the quotient rule. This is a fairly complicated differentiation rule. So how does this go? We have f and g, and we take the quotient. That is, we take a ratio, and we want to find the derivative of this. The derivative of f divided by g. Okay, so how does it go? It goes g f prime minus f g prime divided by g squared. Okay, it's kind of complicated. It's important to remember there's a minus sign here. It's important to remember that you first differentiate f and then you differentiate g. One way people memorize this is using the following sing-song. Instead of writing f over g, they write high over low. And then the bottom function is the low function, that's g. So this formula can be thought of as low, and then I take d, derivative of the high function, that's f prime, minus high, that's f, times the derivative of the low function, so that's d low, and then divided by low squared. So the sing-song goes low d high minus high d low divided by low squared. Okay, so however you want to memorize it, you got to memorize it for the problems that we're going to do. Here's an example of a problem that you can use the quotient rule for. So we have 3x minus 2 divided by 2x plus 2. In this example, the function f is 3x minus 2, that's the numerator. The denominator is 2x plus 2. And now we want to apply our formula. What does our formula say again? It says that if I take the derivative of a quotient like this, I end up with just g f prime minus f g prime divided by g squared. Okay, so let's apply it in this situation. So what do I get? dy dx is going to be equal to, well, the first thing is the g, which is the denominator, 2x plus 2, which I set off with parentheses, and then times f prime, which is the derivative of the numerator. The derivative of the numerator is just 3. And now I subtract. I subtract off f, which is 3x minus 2, which I set off with parentheses, times the derivative of g, which is, derivative of g is just 2. Now I divide everything by the denominator squared, g squared. And that's it. That's your derivative. Now, in a lot of these problems, you can actually simplify, and let's do that here. If I can simplify the numerator, if I multiply things out, so 2x times 3 is 6x, plus 2 times 3 is 6, minus, now I have 3x times 2, which is 6x, and now I have a minus 2 times 2. Now 2 minuses make a plus, so I get a plus 4, divided by 2x plus 2 squared. Now notice here, the 6x minus 6x, they cancel. So in the end, I'm just left with 10 divided by 2x plus 2 squared. Okay, so that's a simplified version of the derivative. Let's see another example. Find the derivative of 2t squared plus 3 divided by e to the t minus 1. So in this case, my numerator f is 2t squared plus 3, and my denominator g is e to the t minus 1. My formula again is the derivative of f over g prime is going to be equal to g f prime minus f g prime divided by g squared. Okay, so let's apply that formula in this case, and we find we get, as a derivative, we get e to the t minus 1, that's our g here. We set off with parentheses, and then times f prime, the derivative of f is going to be 4t by the power rule. Now I have to subtract f, which is 2t squared plus 3, times the derivative of g. The derivative of g is the derivative of e to the t, which is just itself, so I just write e to the t. Now I divide everything by e to the t minus 1 squared. And so that's the derivative of my function. Okay, let's move on to one last example. P is equal to t over ln of t squared plus 1. I want to find the derivative of p with respect to t. My top function f is equal to t. My bottom function g is equal to ln of t squared plus 1. And I want to apply the quotient rule. Here I'm going to do it from memory, so I'm going to say dptt. Well, I have the low function, ln of t squared plus 1, times d high, the derivative of the top function. The derivative of t is just 1, minus. Now I have to take t, That's my f. Now I'm going to take g prime. What's the derivative of g? Well, it's complicated because it's a composition of t squared plus 1 and ln. So I'm going to use the chain rule. So I have an inside function t squared plus 1, and then I have an outside function ln. The derivative of the outside function is 1 over, and it's 1 over t squared plus 1. But then I also have to multiply by the derivative of the inside function, which is 2t. Okay, that gives me low d high minus high d low, and now divide by low squared. That is ln of t squared plus 1 squared. Okay, I can do a little simplification. Ln of t squared plus 1 minus, and then notice there's a t and the 2t, so I can write this as 2t squared divided by t squared plus 1 and divided by ln of t squared plus 1 squared. Okay, you could further simplify by finding a common denominator in the numerator, but we can leave this like that.